When we're writing code, there are some aspects of how we use variables that can improve readability and maintainability. In this video, I'm going to talk about scope, span, persistence, and binding time. Scope is the portion of your code that knows a variable exists, so it's a measure of the structure of your code. The principle of information hiding says that we want to keep the scope of a variable or a method as small as possible. This limits which code can mess up a variable, and therefore limits the portion of the system where you have to go to look for bugs. Designing your system to limit scope results in a system that is partitioned into functional areas. That helps you find the pieces of code because you know where they ought to be. And it limits the amount of the system that you have to understand to be productive. Languages have different ways for you to control scope. For languages where you have to declare variables, often where you declare it defines its scope. Generally, if a variable is declared within a function or method, it's only visible within that routine. And the scope might be even smaller than that. For example, in Java, if a variable is declared inside a method, its scope is from that declaration to the end of the smallest pair of curly brackets that contains that declaration. Variables that are associated with a routine are called local variables. Variables that can be accessed from the entire system are called global variables. For example, in C, if you declare a variable outside of a function, it's global and can be seen by code in files other than the one where it is declared. That's true of Python too, but Python also gives you the ability to mark a local variable as global at its declaration. As a general rule, global variables are a really bad idea. If the whole system can play with a variable, it's really easy for two parts of the system to conflict in how or when they are using that variable. And that can result in bugs that are very hard to debug. You have to look at the whole system to figure things out. In fact, global variables are so risky, standards are opposed to them. For example, the MISRA C standard says it's considered good practice to avoid making identifiers global except where absolutely necessary, in the 2004 C only edition. In many languages, there are scope levels between global and local, and the idea of scope can be applied to routines as well as to variables. In Java, you can control the scope of methods and instance variables with modifiers at their declaration. That lets you decide whether the scope extends to a package, which is essentially a folder of classes within the system, to subclasses of the declaring class, or to the entire system. Note that Java calls the portions of the system packages, which is very similar to namespaces in C++ and C#. C# has similar declaration modifiers, but you can see that they have use within current assembly, kind of like Java uses the idea of a package. An assembly is code you've compiled into a DLL or an exe file. So those scopes are defined by the build process, not by the source code. Scope is one way for measuring how wide access to a variable or routine is. Another measure for that, when we're talking about local variables, is span. Span is the distance between two sequential references to a local variable. The bigger a span is, the more chance that someone will insert code that makes the second reference no longer valid, or that someone will forget what the variable is used for and change its value incorrectly. I like to think of span two ways. I can say keeping span small increases readability, or keeping code readable keeps span small. Clearly, span is limited by scope, so keeping scope small also helps keep span small. Here are some other ideas for how you can keep span small. Some of these have to do with declaring and initializing variables. Check out the link above for a video focused on that topic. Scope and span are both a measure of the structure of our source code. Another aspect of our variables that we want to control is its persistence. That's the time when a variable exists in a running system. So it's the time from when space is allocated for the variable to the time when that memory is released. Here are some possibilities for how a variable might persist. So, why do we worry about persistence? Well, trying to access it when it's not persistent, it can cause all kinds of trouble. Suppose, in an object-oriented language, you try to access an object before the constructor has created it. Well, that won't go well. Suppose in C, you free dynamic memory, but you don't null out the pointer. If you chase that pointer later, you'll get whatever is in memory at that time. Maybe it still has its old value, if nothing else has used that space. Or maybe it has some totally new value because that space is actually holding something else. So just like scope, we'd like persistence to be as small as possible. We don't want to leave things laying around in memory beyond the time when we need them. The longer it's laying around, the more chance there is that it'll get corrupted. There's one other aspect of persistence that we should pay attention to. Just because the memory has been allocated, it doesn't mean it has a useful value in it. We call the time when a variable gets its value its binding time. When we're coding, we like the binding time to be as late as possible because that gives us more flexibility. Bottom line, keeping scope, span, and persistence as small as possible makes our systems more robust and makes our code more readable.